Hello, future toppers. Let's make maths simple, intuitive, and fun together. So, we got wholesome new session in which we will understand the concept of geometric progression. Earlier, you guys have handled arithmetic progression. Now, it's time for geometric one. Now, how this series will proceed? Suppose that you have taken a number A. Okay, it can be anything other than 0. Now you have multiplied a specific constant other than 0 again. Okay. So, and you kept on multiplying that constant throughout the sequence. Okay. So, suppose you have multiplied it by r. So, you got ar. Now, again you have to multiply by r square. Again you have multiplied by r cube. Again you have multiplied by ar power 4 and so on. Okay, so this is your geometric progression. Okay, as it is progression, this means you can find out the formula for nth term. So suppose that we are interested in finding the formula for nth term. So if you'll observe, in every term there exists a. So I feel that in nth term also there will be a. Now focus on r. What is the power of r in first term? It is 0. Second term 1. Third term 2. Fourth term 3. Fifth term 4. Means if I am quoting a random term, you are reducing the power by 1. So if I am interested in finding the nth term, you will put power as n minus 1. So this is the formula for nth term, ar to the power n minus 1. So this is formula for nth term. Okay, now it's time to crack the sum of series. So suppose that it is a plus ar plus ar square plus dot 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 at the end ar to the power n minus 1, and we are interested in finding the sum of this thing. Okay, suppose that what we did, we have multiplied a constant r throughout the series. So it will become rs, a will become ar, then ar will become ar square, then ar to the power n minus 1 plus ar to the power n. So this thing we will get. Okay, so suppose that this is your sequence, this is 1, this is 2. Okay, and what we did, we did 1 minus 2. So what we will have, we will have s 1 minus r equals a minus ar to the power n. This thing will be neutralized. Okay, you can also take a common and we will be left with a times 1 minus r power n. Now can I write s as a, I will take minus 1 common, okay, from numerator. So r to the power n minus 1 by r minus 1. So this is your sum of n terms. Okay, now suppose that you have to talk about sum of infinite terms. So in case of infinite, look at this. Who is a over here? Try to understand who is a. So a is the first term. Who is r? R is Tn by Tn minus 1. This is common ratio. Okay. Now, suppose that we are interested in finding the sum of infinite terms. So, in that case, the r should be smaller than or mod r should be smaller than equal to smaller than 1. Okay, so in this case the series will become decreasing, means the value of element will keep on decreasing. Okay, so in that case this element, suppose it is 1 by 2, 1 by 2 power n, and n is infinite, so 1 by 2 power infinite will become 0. Okay, so this element will vanish, so s infinity will become minus of a by r minus 1, or you can also say that a by 1 minus r. Okay, so these things you have to memorize. A by 1 minus r. So if someone will ask you what is the formula of nth term in geometric progression, you will answer a r to the power n minus 1. If they will ask you to find out the sum of n terms in an GP, you have to answer a times r to the power n minus 1 by r minus 1, and sum of infinite terms you will quote as a by 1 minus r. I hope the idea is clear and you guys can apply these concepts into appropriate questions and you guys can get accurate answer. So see you guys in next session of Mathflix.